Hello everyone, today's video is on solving systems of equations, particularly the substitution method. This is an algebraic method of solving systems of equations. So let's say we are running a concession stand at a baseball game, and we are selling hot dogs and sodas. Each hot dog costs $1.50 and each soda costs 50 cents. At the end of the night, we make a total of $78.50. And we know that we sold a total of 87 hot dogs and sodas combined. We don't know the specific number of hot dogs or the specific number of sodas, but we know that those two numbers combined make a total of 87 things that were sold. So our goal here is to find out how many hot dogs and sodas were sold. So the first thing we need to do here is define our variables. So variables, as we know, represent unknown quantities. So in this case, the quantities that we don't know are the number of hot dogs, number of hot dogs, and so I'll use the variable h for that, and the number of sodas. And you guessed it, I will use the variable s for soda. Okay, now that we have our variables established, we need to write a couple of equations to solve for these variables. So, if I know that each hot dog costs $1.50 and each soda costs 50 cents, and at the end of the night we made $78.50, well, I know that I can multiply $1.50 by the number of hot dogs, and I can multiply 50 cents by the number of sodas, and that will get me my total for the night, $78.50. So 1.5h plus 0.5s equals 78.5 is my first equation. Okay, but we still have two variables here, and we can't solve for both variables with just one equation. So we need another equation. So what else do we know? Well, we know that we sold a total of 87 items, both hot dogs and sodas combined. So that means that h plus s must equal 87. And there's my second equation. So now that I have my two equations, I can go about using substitution to solve for both variables. So substitution involves solving for one of the variables in terms of the other so that we can use that expression and substitute that back in for that variable. And I'll show you what that looks like here in just a minute. So my goal is to rearrange one of these equations to end up with h equals something or s equals something. Whenever I've isolated one of those variables, I have an expression that is equal to that variable. So that's my goal here. And it doesn't matter which one I solve for, so I will solve for s in this case. So if I look at this second equation, that one is a little bit simpler, so I prefer to use that one. If I take h plus s equals 87, the only thing I need to do to solve for s is to subtract h from both sides. So I end up with s equals 87 minus h. Now I have an expression, 87 minus h, that is equal to s. And so now what I'm going to do is I'm going to take that expression, go to my other equation, the first equation, and I'm going to substitute that expression in anywhere I see that variable s. So let's look at what that looks like. So my first equation here is 1.5 h plus 0.5 s equals $78.50. So I'm going to take this expression that I found for s, bring it all the way over here, and substitute that in for s. And so my equation is now going to look like 1.5 h plus 0.5 times, not s, but this expression that we found for s, 87 minus h, and that equals 78.5. And so now I have an equation with just one variable that I can solve fairly easily. So my distributive property says that I need to multiply 0.5 by everything inside the parentheses. So I'm going to do that. I'll pull my calculator out here. 87 times 0.5 is 43.5. So I end up with 43.5, and then 0.5 times h is just 0.5h. So I have 43.5 minus 0.5h. And then I still have my 1.5h over here. Alrighty. And we'll finish writing out the rest of my equation. The next thing I can do here is simplify by adding like terms. I see negative 0.5h and 1.5h. If I combine those together, 1.5 minus 0.5 gives me 1. So that's just 1h, which is just h. So now I have h plus 43.5 equals 78.5. All right. And now I can solve for h by subtracting 43.5 from both sides. Let's see, we get a 0 here, we get a 5 here, and we get a 3 here. So 35 on the right side and h on the left side. So we know now that h is equal to 35. All right, so that means that we sold a total of 35 hot dogs. All right, but how many sodas did we sell? Okay, well, we can easily take this value for h, plug it into one of our equations, substitute it back in, and find out what s is. So to do that, I'm going to take, again, the simpler of the two equations. H plus s equals 87. H plus s equals 87. Take this h, plug it in there. Zoom in so you can see a little better. So we have 35 plus s equals 87, and then we just solve for s, subtract 35 from both sides. We get s equals 52. S equals 52. So that means that we sold a total of 52 sodas and 35 hot dogs. So that is a demonstration on how to solve systems of equations using the substitution method. Thanks for watching.